We want to start with the domain here. So we want to identify what are we actually taking the log of? What's our input here? So we're taking the log of, it's like a repeat of what just happened. Thanks, x minus 3. So we're taking the log base 2 of x minus 3. So this is what's being put into the function. So we know this part, we need to take the log of a positive number. So this has to be positive. So then we add 3 to both sides. We get x is greater than 3. So we get 3 to infinity. Okay, and now we want to graph. What is the base for this function? Base 2, because it's negative log base 2 of x minus 3. So we have base 2. So I'm going to write my points. I'm going to use this as a reference. So I know it's going to be 1, 0. The base is 2, so 2, 1. And then the reciprocal of the base, negative 1. And then x equals 0. Okay. Now we have to come and take a look back, and there's two things happening here. What is this going to do to every point? Is this negative with the x or with the function y? Is it touching x or touching y? Y. This is going to change your y value, all right, because the negative would have to actually touch the x to change the x. So I know y is being impacted here. So this is opposite y. So we have opposite y. And then what about this? What's going to happen here? This is going to go right. So what's going to happen to each x? X plus 3. Now because one step is changing y, and the other step is changing x, we can do this all in one step so we don't have to like write the points over and over. So I'm going to first change all of my x's. So I'm going to add 3 to each x. What's 1 plus 3? 2 plus 3? 1/2 plus 3? 3.5 will suffice, or you can write 3.5. All right? And then 0 plus 3. 0 plus 3. 3. All right, and now we need to do the opposite y's. So we have 0, negative 1, and positive 1. All right, and then now we have everything we need to graph. This is it. So we have 4, 0. We have 5, negative 1. We have 3.5, 1, and then x equals 3. So our graph is going to look like this.
Do you just think estimate was like the dots are going to be?
Like the 3.5. I plotted these points, and then I had just drawn my tick marks. Now, some of you are like, how did we know it was going to curve this way or look like this? So a couple things to think about. One, we had the asymptote. So we know that this arrow is going to either go up to the asymptote or down. Your parent function for logs, we know, kind of looks like this always. Okay. So this is your parent function, but if there's an opposite y value, then that's going to flip over the x-axis. So where this was down, it's now up. So this is the reflection over the y-axis. So this is how we knew the shape was going to kind of look like this instead. So once you have your points, then we know we're kind of going down instead. Okay. So what is the range of every log function? Negative infinity to infinity. What is our asymptote? X equals 3. Okay, to find the inverse, what do we do always to start algebraically solving for the inverse? So we have x equals negative log base 2 of y minus 3. Now I want to draw your attention here. On this side, we only have one term, but our goal in terms of switching forms, we always need to isolate the term. So there is this negative in front. Now we're not adding or subtracting on the outside. If we did that, we would have to also move the extra term. But we do have the negative, so I'm going to divide both sides by negative, or multiply both sides by -1, either or. And now we need to change forms. All right, do you guys remember the two questions? What's the base and what's the exponent? So here, what's the base? 2. Now logs are always exponents, so what's the exponent here? I'm sorry? No, the exponent, logs equal exponents. So if this is the log, what's the exponent? Negative x. And then what's left over? Y minus 3, and the final step in solving for y. So then we have 2 to the negative x plus 3. So this is our inverse function, which is exponential. We knew that would happen because logs and exponential functions are inverses. What is the convenience again? If we want the domain and range of this exponential function, do we have to actually calculate it? Do we have to use this to actually figure this out? Why not? The domain of the log is 3 to infinity. How does that help us? Yeah, all the x's and y's are switched. So the domain for the log is the range for the exponential function. So this is 3 to infinity. And the range of the log function is the domain, because all the x's and y's are all flipped because they're inverse functions. So you do not need to calculate the domain and range of the inverse because you already had it for the log function. Everybody good?
So it stays the same.
Yeah, yes and no.
No.
The values are the same, but notice the domain of the log
Is the range?
is the range because all the x's and y's
Oh, wait,
switch. They flip.